Good morning everyone. Today we are going to discuss aromatic hydrocarbons, specifically the methods of preparation of benzene, its chemical properties and reactions. Let's get started. Preparation of benzene is an essential chemical process with many applications. It is generally prepared from aromatic hydrocarbons, typically derived from petroleum sources. Common methods of preparation include catalytic reforming, thermal cracking, and hydrocracking. These processes involve molecular rearrangement of the hydrocarbons to form benzene. At a temperature of 873 K, passing acetylene through a red-hot iron tube can result in the ionization of the carbon, which allows it to form a cyclic, or trimerized polymer, known as benzene. This process is referred to as trimerization or cyclic polymerization. Phenol can be used as a reducing agent to form a benzene ring through a reaction catalyzed by zinc oxide, in which a zinc molecule serves as a source of hydrogen. This reaction leads to the removal of oxygen atoms from the phenol to generate a benzene ring, and is thus an example of a reduction reaction. The reaction of preparation for aromatic hydrocarbons such as benzene is known as the Friedel-Crafts alkylation. In this reaction, aluminium chloride, a strong base like NaOH or SaO, or an iron catalyst such as iron 3 chloride can be combined with sodium metal or sodium carbonate, C6H5 Cuna, to produce C6H6, plus sodium carbonate, Na2CO3. The answer to which of these is the reaction sought is Friedel-Crafts alkylation. Benzene is a unique aromatic hydrocarbon which has a special structure and chemical properties. Its structure consists of a 6-carbon ring which is surrounded by 6 hydrogen atoms that have a planar arrangement. This special structure gives benzene its unique chemical properties, which can be divided into 2 major categories: reactivity and stability. Its reactivity is mainly caused by its high electron-rich structure, which allows it to take part in many different reactions. Its stability is mainly attributed to the fact that it does not undergo any rearrangement reaction under normal conditions. Taking into account its unique structure and chemical properties, benzene can be used as a starting material for many other aromatic compounds. Benzene's chemical properties are largely attributable to its structure. All of the bonds in its ring can be delocalized, with electrons distributed throughout the molecule. This delocalization explains why structures I and E do not exist. The electrons that would have been in the double bond would instead be delocalized around the ring. Consequently, the structure of benzene features delocalized electrons. This delocalization results in benzene acting as an electron source, so it undergoes electrophilic substitution reactions. Benzene is an aromatic hydrocarbon that is used in many industrial processes because of its special chemical properties. It can be processed through traditional methods such as distillation and fractional crystallization. Additionally, certain conditions can make benzene undergo addition reactions. When heated with hydrogen gas in the presence of a nickel catalyst between 453 K and 473 K, cyclohexane is formed. Knowing how benzene is processed and its chemical properties, as well as the reaction conditions, is necessary to guarantee successful addition reactions. Benzene reacts with chlorine in the presence of bright sunlight or UV light to form benzene hexachloride. This reaction is an addition reaction, as 3 molecules of chlorine are added to the benzene. Benzene hexachloride is a white crystalline solid, with a distinct chlorine-like odor. The reaction is exothermic and is an effective industrial method for producing benzene hexachloride. Benzene is a highly useful aromatic hydrocarbon. One of the more popular methods of producing it involves creating benzene hexachloride, also known as Benzene or lindane. This is achieved by combining sunlight or ultraviolet light with 3 chlorine molecules. Benzene hexachloride is then used as an insecticide due to its homolytic fission. It remains a valuable chemical compound for a variety of purposes. Ozone added to benzene results in the formation of benzene triozonide when it reacts with 3 molecules of ozone in the presence of water and zinc. Further, this reaction yields glyoxal, an important product with multiple applications in the chemical industry. Glyoxal is oxidized into benzene triozonide by adding Zn as a reducing agent which prevents further oxidation. Subsequently, benzene triozonide is hydrolyzed using 3H2O to produce benzene. Phenol is an organic compound with a characteristic smell. When it reacts with zinc, it can produce either benzene or benzoic acid. The answer is therefore C. Benzene. Benzene reacts with chlorine under the influence of bright sunlight to produce various products. One of these products is the chlorobenzene or benzyl chloride, BHC or gamexane, and parachlorobenzene. When subjected to certain temperatures and pressures, acetylene undergoes cyclic polymerization to yield benzene. This reaction does not involve reduction, oxidation, or any of the other choices given. Therefore, the answer is A. Cyclic polymerization. What would be the final product of the reaction of benzene and ozone? 4 possible products are benzene triozonide, A ketone, B, a carboxylic acid, C, and benzene, D. Benzene is a highly reactive compound with a variety of industrial applications. It can form organic compounds by the addition of electrons or through oxidation and reduction reactions. Additionally, it is used in the synthesis of phenol, aniline, and cyclohexane. Moreover, benzene is very stable in liquid form, which makes it easy to store and transport. Its boiling point is traditionally low, at 82 degrees Celsius, making it easy to use in industrial processes. Substitution reactions involve replacing one or more hydrogen atoms of benzene with groups such as chlorine, bromine, nitrate, and sulfate. This alters the molecule's properties and the way they react. Moving on, government takes various steps to safeguard the health of its citizens. Nitration of benzene involves substituting the hydrogen atom of the benzene molecule with a nitro group. When heated with a combination of concentrated hydrochloric acid and sulfuric acid, nitrobenzene is formed. Examining how freedom is depicted in Walt Whitman's poem, I Hear America Singing, is the next step in our exploration. Halogenation involves the substitution of one or more of the hydrogen atoms of benzene with either chlorine or bromine. These reactions are often used to produce solvents, dyes and medicines, and can be useful for making chemicals with different practical and commercial applications. This slide focuses on the chlorination of benzene. We observe it using anhydrous aluminium chloride, with an HCl molecule as an electrophile. The result is chlorobenzene and AlCl4 as a byproduct. It is an example of how substitution reactions can be used to add a substituent to benzene. Chlorine is used to replace the 6 hydrogen atoms on a benzene molecule in this reaction. Anhydrous aluminum chloride and excess chlorine act as catalysts in this substitution process, leading to the formation of hexachlorobenzene, which comprises of 6 chlorine atoms instead of hydrogen atoms on the benzene ring. Benzene and bromine in the presence of iron 3 bromide react in a process called bromination, producing bromobenzene, C6H5 bridge. Bromobenzene is an organobromine compound that can be used to synthesize pesticides and pharmaceuticals, but also has interesting chemical properties and reactions that must be taken into account when using it. Sulfonation is a process of reaction in which hydrogen atoms of the benzene molecule are substituted with a SO3H group. The result of this benzene sulfonic acid reaction is that the benzene molecule gains increased reactivity, leading to an increased range of possible reactions. At 373 Kelvin, benzene reacts with oleum, composed of hydrogen sulfuric acid and sulfuric trioxide, to produce benzene sulfonic acid. At 373 K, fuming H2SO4 can be used to prepare benzene, resulting in benzene sulfonic acid being formed. The acid is a combination of H2O, So3H, and benzene H. Additionally, H2SO4, also known as HO, So3H, is produced from the reaction. Hexane, benzene, nitrobenzene, and aniline all react with nitric acid, with the product of the reaction being X, which is concentrated sulfuric acid. This chemical equation illustrates how aromatic hydrocarbons are able to have multiple reactions with different products. In this reaction, the electrophile attacking is SO3H. Through sulfonation, we can add the sulfonic acid group to benzene, giving it the possibility to take part in a more extensive range of reactions. Benzene is an aromatic hydrocarbon that is a colorless liquid with a sweet odor. It is a combustible fuel and is highly flammable. It is also known for its unique chemical properties, which are due to its structure of alternating double and single bonds. In this presentation, we will discuss the chemical properties of benzene and its reactions. We will focus on topics such as reactivity, aromaticity, and reactivity with halogens. Lastly, we will address the most important reaction of benzene, the electrophilic aromatic substitution reaction. Let's explore the chemical properties of benzene. Benzene can be substituted by a wide range of alkyl groups, a process known as Friedel-Crafts alkylation reaction. The next slide discusses the various components necessary to be successful in participating in a team sport. An alkylation reaction is carried out when treating benzene with an alkyl halide in the presence of anhydrous aluminium chloride, which results in the formation of an alkyl benzene. To ensure the formation of the desired product, this reaction requires a highly selective catalyst. It is used to synthesize a variety of different products. Anhydrous aluminum chloride, HCl, and low molecular weight alkenes such as toluene are used to start a Friedel-Crafts alkylation reaction. Methyl chloride is added as the electrophile and reacts with the anhydrous aluminum chloride, resulting in the formation of the desired benzene product and of AlCl4 as the byproduct. Friedel-Crafts alkylation reaction is a common way of preparing benzene. In this reaction, benzene is treated with an acyl halide or acid anhydride, and anhydrous aluminium chloride is used as a catalyst. The result is acyl benzene. This reaction is beneficial as it allows for economical synthesis of benzene, and further allows for various other reactions. This slide is about the method of preparation of benzene using acetyl chloride. Acetyl chloride, abbreviated as CH3CClO, is reacted with anhydrous aluminium chloride, forming an alkylium ion, which then reacts with methanol, CH3OH, forming acetophenone and HCl. The end result is benzene, C6H6. Alkylation of benzene gives alkyl benzene as the answer among the choices of toluene, benzene hexachloride, alkyl benzene, and acetophenone. The most common mechanism for alkylation of benzene is nucleophilic substitution, where a nucleophile attacks the benzene ring. Electrophilic substitution also occurs, where an electrophile attacks the benzene. Free radical substitution involves the attack of a radical on the benzene ring, while addition reaction involves the addition of a reactant across the double bond of the benzene ring.